Composite function. Hi students, our study today is about composite function. What is a composite function? Suppose you have a function x, you have a variable x under a function f. So there is a relation which will take us to y equal f of x. So you have x, you have its final set, which is y, under function is called f. Then suppose we have a continuation of another function g that will take y to another image z. Z is g of y. So we have y equal f of x, then we have z equal g of y. But since y is f of x, so z will be g of f of x. Let us take an example. Suppose here you have initial value x, initial, and this is final, and here you have a function f where y equal f of x equal, for example, square. You're squaring every number. So if you have 2, the image of 2 square is 4. Then we're going to go from 4 to another function. This function is called g. For example, suppose g of x is a division, which is 1 over x. So here you're going to get 4 will be 1 over 4. Okay, so we have two functions. In the first one, we had y equal f of x equal x squared. In the second, we had y equal g of x, okay, which is equal 1 over x. Okay, so here we have two different functions. So you can go directly instead of doing it from here till here, then from here till here. So we can go directly under two functions f and g by writing z, for example, equal g of f of x. So what's z equal g of f of x? It's a composite. It's two functions, two consecutive functions. The first function we're going to say is g of f of x. We read the o is of f of x. First of all, we do operation f, then we do operation g. So this is called the composite function, and it's denoted g of f of x and g of f of x, g f of x. You may have more than three operations. You may have g of f of k of x. Suppose the first function k, for k, if you have x, you have you do the double, and then you have the function f, you square. If you have x, you square it, and then the last one, suppose g, you divide. X will be 5 over x. Suppose you're going to start by a number x is 10, so this will be 10. We'll do first of all k, it will be 20. So this is the answer of k. Then you have f of 20, it will be 400. Then we're done with the f. Then we have a g, so it will be 5 over 400. So composite function, it's a relation between function. Let us take example. Let us take y equal f of x equal 3x minus 4 and y equal g of x equal x plus 2 over x minus 1. Find first of all f of 3. F of 3 is very simple. You replace x by 3. 9 minus 4 is 5. You want f of g of minus 1. So you have f of g minus 1. We do first of all g of minus 1, the first operation g. We go to g here and you replace x by minus 1. You're going to get minus 1 plus 2, which is 1 over minus 2. Okay, so 1 over minus 2 is minus 0.5. So g of minus 1 is minus 0.5. So I have now f of minus 0.5. So I replace x by minus 0.5 and I get minus 5.5. I want f of g of minus 2. So for the first step, I do g of minus 2. So minus 2 plus 2 is 0. So I have g of minus 2. It's already done. So now I have f of this 0. F of 0 here is minus 4. I go to f, I replace x by 0. So minus 4. So remains 1f. f of minus 4, it will be minus 12 minus 4 minus 16. Now I want to write it in terms of x. I want f of g of x. In f of g, so f of g, I go to f, this is f, I replace the x by, this is x, I replace this x by g. So it will be 3g minus 4. But g is this whole expression, so I replace it 3 into this whole expression minus 4. I want g of f of x, so it's g of f. I have g of f, so I go to g, I replace this x by f, so it will be f plus 2 over f minus 1. Sorry, this is f plus 2 over f plus 2 over f minus 1. But f is 3x minus 4, so I replace, it's 3x minus 4 plus 2 over 3x minus 4 minus 1, so it will be 3x minus 2 over 3x minus 5. Now I want f of g of f of x. So I do first of all g of f of x alone. So it's g of f. G of f of x already done here. Suppose it's k. Name it by k. So instead of having f of g of f of x, since this is k, so you have f rho k of x, so it's f of k. So you go to f, you replace this x by here by k. So it will be 3k minus 4, and k is nothing else than this whole expression. As you can see, a composite function, very simple. I want f of 2 here. I go to f, I replace x by 2, so minus 6 plus 2 and plus 1 is minus 5. I want f of g4, so it's f of g4. I do first of all g4. 8 plus 3, 11 over 6. So I have f11 over 6, so it will be minus 3 into 11 over 6 plus 1, and you have this calculation. I want f of g of k of 3. First of all, I do k of 3. K of 3, radical 9 is a 3 times 2, 6 plus 1, 7. So K of 3 is 7. So I have now after G. G of 7. So 14 plus 3, 17 over 9. Then I have the last one, F of 17 over 9. I do it here, replace it, I get the answer. I want F of G of X. It's F of G. I go to F, I replace X by G, minus 3G plus 1. But G is this whole expression. So this expression, I replace it here. Plus 1. I want k of f of x, so k of f, so I go to k, I replace this x by f, and f is nothing else this whole expression. Okay, I replace it. I want g of f of k of x. So first of all, we do f of k. We go to f, we replace x by k, minus 3k plus 1, but k is this whole expression. I replace it here, I expand, you have this one. Let us name it by r. So instead of doing g of f of k of x, since f of k of x is r, so g of r directly. So I go to g, I replace these two x's by r, 2r plus 3 over r plus 2, where r this is this whole expression where I replace it. So as you can see, this is the composite function. It's something very simple. Hope that you got this chapter, this part.